welcome to another session of prep. And what we're going to do today is we're doing more balancing equations, you lucky little sausages you, but this time I'm going to show you the TALLY method. Now with the mathematical side of chemistry, it doesn't necessarily matter how you get to the answer. So as long as you're happy with the approach that you're using, that is all good for me. This is my favourite approach to balancing chemical equations. Okie dokie, when balancing a chemical equation, what we need first is an equation to balance. So let's go for something like this. So let's have aluminium tribromide reacting with potassium to make potassium bromide. This is an example of a displacement reaction because the potassium is more reactive than the aluminium, so it's going to displace the aluminium from the bromine and leave you with potassium bromide and aluminium by itself. Okie dokie. So what I would do in my tally chart method, I like to break up each side of the chemical equation. Then I write a little list of the chemicals that I have present. So capital A, little l is aluminium. I do like making the L's extra kind of flicky just to make sure it looks like an L rather than a capital I. BR, capital B, lowercase r, stands for bromine, so that is an element, so BR. And capital K is potassium. Whatever I have on the left-hand side, I must also have on the right-hand side, so I'm not even going to bother reading the right-hand side right now. I'm just going to copy my list from the left-hand side. Then what I do is make a little tally chart of how many of each element I have got. So on this left-hand side here, I've got one lot of aluminium. There's no kind of number that was next to our aluminium, so there's just one of it. The bromine here has got a little 3 next to it, so that means that there's 3 lots of bromine. So I'll do 1, 2, 3, little tally chart like that. And then there's only one potassium, so 1 for potassium. On this side, there's 1 potassium here. There's no numbers next to the bromine, so there's 1 bromine. There's no numbers next to aluminium, so there's only 1 aluminium. So 1, 1, 1. Okay, so on the left-hand side, there's 1 aluminium. On the right-hand side, there's 1 aluminium. That's pretty decent. I ideally want to avoid playing with them. However, on the right-hand side, there's 1 bromine. On the left-hand side, there's 3 bromines. I want to try and fix that matchup somehow. So what I'm going to do, to get from a 3 to 1, or from 1 to 3, I have to times it by 3. Now the bromine is stuck on the right-hand side in a compound with the potassium bromide. Those two are attached together in what is called an ionic compound. Year 10s and Year 11s will know what ionic compounds are. Year 9s might have heard of it, but that there is an ionic compound. Those are attached. You cannot just be very naughty and go 3 there. That doesn't work because that changes what the compound actually is, so you can't do that. Neither can you go 3 there, because that, again, you're breaking up a middle of a compound there. That is not possible. The only thing that we can do is put a great big 3 in front of that entire thing. So that's 3 times everything inside those brackets, okay? We cannot break up the molecule there. So that has given me my 3 bromine, which is great. However, I've accidentally screwed with my number of potassium. So now I've got 3 potassiums on the right-hand side. Oof, what a shame. But then actually, look, I've got 3 here and 1 here. So to get this 1 equal to 3, I could just put a 3 here. And that's exactly what you do. 1, 2, 3. So there we go. On this top row, there's 1. On the second row, there's 3. And on the third row, there's 3. That is a balanced chemical equation. Okay, let's have a go at another one. Okay, so this is a classic one for balancing chemical equations, and I say it's a classic one because people always get it wrong because they try to be naughty. So let's do our tally method again. So once again, I'm just going to break up each side because it helps me kind of separate them, both in my mind and then physically on the paper as well. Capital H stands for hydrogen, so that is one element. Capital O stands for oxygen. There we go. And then same again on the right-hand side. Ho ho. Okay, so let's make a little tally chart of what we've got on the right-hand side and the left-hand side. On the left, we've got 2 hydrogens, so there we go. 1, 2, and we've got 2 oxygens. Fantastic. On the right-hand side, what have we got? Well, we've got 2 next to this hydrogen here, so that means you've got 2 hydrogens here. And there's no number next to this little oxygen, so that just means that there's 1 oxygen overall. So what lots of people try and do at this point is they try to just put a 2 there to make that balanced. That is exceptionally naughty. H2O is 1 oxygen attached to 2 hydrogens, and that is water. Water that we know and love and we need for the environment and for ourselves, for processes to work. We like that. That is lovely. H2O2 is kind of like this business, that's an O there, and that is called hydrogen peroxide, which is also known as bleach. Okay, so just changing one little number there at the bottom completely changes the chemical. Okay, so that's why I keep saying you're not allowed to change the bottom numbers. Mouthful of water and you're going to be good. You're going to have happy times. You're going to be nice and hydrated. Mouthful of bleach, you're going to be very poorly very quickly. Okay, so please don't be changing the bottom symbols. Okay, then so how would we balance it? We've got 2 lots of oxygen here, but only 1 here. We need to make that into a 2. The only way that we're allowed to do that is put a big old 2 at the front. That unfortunately does double that entire molecule, but that's okay. We can deal with this. So that's now given us a total of 2 oxygens. And then we've got 2 times 2, so that's a total of 4 hydrogens on the left-hand side. So look, yay, we've balanced the oxygens, absolutely super. But now we've got 4 over here and 2 here. How can we deal with that? There we go. Job done. Okay, I'm going to do one last one for you. I'm going to choose a nasty one, or one that people perceive to be nasty, and then I'm going to set you loose on some of your own to have a go at. Okay, so what we're going to have zinc reacting with nitric acid, HNO3. That's going to do a cheeky displacement reaction. The zinc is going to see that nitrate group and go, nom, 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 I want me some nitrate. So it's going to steal it all for itself to form zinc nitrate. Now, the formula for zinc nitrate is this. Oof, doesn't that look awful? If you've learnt about ionic bonding, you should be able to tell me why that is the case. If you haven't learnt about ionic bonding yet, then don't worry about it. It's all good. Okay, so same as before, let's divide up the 2 sides. On the left-hand side, capital Z, lowercase n is the symbol for zinc. So let's keep those symbols together. Capital H is the symbol for hydrogen. So that's that one there. Capital N is the symbol for nitrogen. And capital O is the symbol for oxygen. So I've split out all of the elements there. Whatever on the left-hand side must also be on the right-hand side. So let's just very quickly write that down. Not even going to count it up, just going to make it into my list there. Okay, so the left-hand side, I've got 1 zinc. I've got 1 hydrogen, because there's no numbers next to this hydrogen. There's no numbers next to this nitrogen, so there's a 1. And there's a little cheeky 3 with the oxygen, so 1, 2, 3. Easy peasy lemon squeezy. Okay. Let's go to the right-hand side then. There is no number next to this zinc. Therefore, I have just 1 zinc. This next bit here is in brackets. That means that there's 2 lots of this entire bracket. So that means this has got 3 oxygens because there's 2 lots of 3. There's going to be 6 oxygens overall. There's 2 lots of 1 for the nitrogen, so there's 2 lots of nitrogen overall. So for the nitrogen, I need 1, 2, just because I'm using just this little 2 here. The oxygen, it's 2 times the 3, so that's 6 in total. How many hydrogens have I got? Well, this little hydrogen here has only got a 2 next to it, so 1, 2. Okay, that's potentially a bit scary, but let's have a look what we can do with it. The zincs both match, so ideally I want to leave the zincs alone. Let's just do it in the order that it's shown. So hydrogen there, I've got 2 here, I've got 1 here. So I need to double wherever the hydrogen is on the left-hand side. The hydrogen is here, stuck in this great big naughty molecule here. So I'd love to just do that, but you can't do that. It's naughty. I've got to put a great big 2 in front of that entire molecule, and I'm even going to put it in brackets just to help us kind of visualize it a little bit. Okay, so now I've got 2 hydrogens and I've accidentally screwed with everything else. Ugh. Okay, let's just tick off my hydrogens and let's see what damage I've done. I did have 1 nitrogen before, but now I've got 2 lots of nitrogen in total. So there we go. Oh, bonus. Accidental balancing. Love that. And I did have 3 oxygens before, but now I've got 3 here times by the 2 here, so that would be 6. So 1, 2, 3, 4, 5, 6 in total. Oh, 6, 6, boom, boom. Okay, so people often get a little bit worried when it comes to the brackets, but actually, they're not that bad after all.